Hey everyone, and welcome to today's Explainer. Today we're putting on our cosmic detective hats to investigate a absolutely fascinating 53,500 light-year-old mystery hanging high up in the Horologium constellation. We are looking at a globular cluster known as Caldwell 87, and untangling its history is going to require us to pull together clues from orbital mechanics, stellar chemistry, and even ancient galactic collisions.
So let's dive right in. The fundamental question driving this entire investigation today is right here. Is Caldwell 87 a native of our Milky Way, born right here in our own galactic backyard? Or is it an alien import, a remnant from a completely different galaxy that somehow got dragged into our own? To answer this, astronomers have been gathering kinetic and chemical clues from all across the cosmos.
Section 1. Meet Caldwell 87.
Let's start by examining our prime suspect's basic profile. Caldwell 87, which is also cataloged as NGC 1261, was actually discovered way back in 1826 by the astronomer James Dunlop. It sits about 53,500 light-years away from us in the constellation Horologium, and what makes it immediately interesting is its location. It's situated way out in the outer halo of our galaxy, completely removed from the dense, bustling central galactic bulge.
Because it just hangs out in the galactic suburbs like that, we really need to determine its true origin. Did it form in situ, meaning is it native to the Milky Way, forming from our own galaxy's primordial gas? Or was it accreted, meaning it was actually born inside an alien dwarf galaxy that was later captured and just torn apart by the Milky Way's immense gravity?
Section 2. Bouncing cores and blue stragglers.
To figure out where this cluster comes from, we first need to look at some highly unusual stellar behavior going on deep inside the cluster itself. The first major clue comes in the form of blue straggler stars. See, in a typical globular cluster, the stars are all roughly the exact same age. But blue stragglers are anomalous. They appear much brighter, bluer, and seemingly way younger than they have any right to be. They literally defy the normal aging process of the cluster. Astronomers think these stars get this fountain of youth appearance by either merging with a binary companion or by surviving a direct head-on stellar collision.
Now what's really wild is the main driver behind this anomalous behavior, something called a core collapse bounce. Globular clusters can sometimes undergo a phase where their core shrinks rapidly, turning into this incredibly crowded cosmic mosh pit. I mean, this forces stars into super close proximity, dramatically increasing the rate of collisions. Eventually the core rebounds or bounces outward, but it leaves behind a whole generation of those youthful-looking blue straggler stars as evidence of the chaos.
And when we look at the color magnitude data from the Hubble Space Telescope, we don't just see a random scattering of collisions. We actually see two very distinct sequences of these blue straggler stars. The fact that these sequences are neatly divided into blue and red camps practically proves that multiple, distinct, violent collision events took place at very different times in the cluster's history, rather than just ongoing random collisions.
Tracing this observational data against theoretical models gives us a wild, incredibly specific timeline for our suspect. Caldwell 87 was likely born about 10.3 billion years ago. Then, fast forward to about 2 billion years ago, it suffered a massive core collapse, which created that first sequence of blue stragglers. And astonishingly, it underwent a subsequent core bounce just 200 million years ago, generating a totally fresh, extremely blue batch of collision stars.
Section 3. The chemical fingerprints.
Okay, so the internal dynamics are super fascinating, right? But to definitively find out where the cluster was born, we need to examine its chemical DNA. High-resolution spectral analysis reveals that Caldwell 87 is moderately metal-poor, which, is pretty typical. But it contains heavy elements consistent with something called R-process nucleosynthesis, which is just a really complex way of saying it was seeded by a deeply violent cosmic event. Most notably, it features a highly anomalous overabundance of a heavy metal called europium.
And honestly, this is a massive clue. Europium is generally forged in the most extreme environments in the universe. So this specific europium signature acts as a sort of cosmic DNA test. It quantitatively suggests that a single massive R-process event, more than likely a cataclysmic merger between two neutron stars, seeded this exact cluster with heavy elements before it ever joined our galaxy. This perfectly matches the chemical profile of R-process enhanced stars that are commonly found in dwarf galaxies, not in the Milky Way.
Section 4. Tracing the cosmic orbit.
So now that we have chemical evidence pointing to an alien origin, let's see how this builds by mapping exactly how it moves through space. Point 86. That single number represents the cluster's orbital eccentricity. Now, a perfectly circular orbit is 0. A 0.86 means Caldwell 87 is moving on an incredibly radical, non-circular, and highly radial path. It is essentially plunging straight into the galactic center and shooting right back out to the halo, rather than orbiting smoothly around the disk like our native stars do. When astronomers map out the cluster's energy and velocity in what's known as action space, which is essentially a multi-dimensional map of its momentum, Caldwell 87 lands perfectly in a highly elongated orbital grouping. It sits right at the extreme edge of radial momentum, part of a very distinct sausage-shaped cluster of orbits that completely defy the normal rotation of the Milky Way.
Section 5. The Gaia-Sausage Connection.
All right, this brings us to the grand reveal of our detective story. That highly radial 0.86 eccentricity orbit, that is the exact, undeniable signature of the Gaia-Enceladus merger, affectionately known by astronomers as the Gaia sausage. Between 8 and 10 billion years ago, a massive dwarf galaxy plunged right into the Milky Way on a highly radial trajectory. It was completely torn apart, heavily shaping our inner halo and depositing its native stars and globular clusters into these exact plunging orbits.
And this leads to a really definitive conclusion from the Koch-Hansen research team, pulling together all the clues we've looked at. They state, combining all kinematical, age, and chemical evidence, we conclude that NGC 1261 is a chemically intriguing globular cluster that was born in the Gaia-Enceladus galaxy and has been subsequently accreted into the Milky Way halo. The mystery is absolutely solved. Caldwell 87 is, unequivocally, an accreted alien import.
But, solving this mystery really just opens the door to an even bigger one. I mean, think about it. If a cluster this dynamic and complex, carrying the scars of collapsing cores, neutron star mergers, and a billion-year intergalactic journey, was born in another galaxy entirely, it leaves us wondering, what other alien worlds and ancient galactic fossils are orbiting right above our heads, just waiting for us to piece their clues together? Thank you so much for joining me on today's Explainer, and as always, keep your eyes on the stars.